Hi, my name is Hamza, and today we are going to discuss functions in C++. So let's start. Functions. Think of a function in programming like a mini program inside your main program. You give this mini program a name. A function groups a number of program statements into a unit and gives it a name. This just means you take a bunch of instructions, or you can say program statements, that do a specific task and bundle them together under a single name. Imagine labeling a set of instructions like calculate average. Second, this unit can be invoked from other parts of the program. This just means once you've named your mini program, for example, calculate average, you can tell your main program to run it whenever you need to calculate an average. It's like having a button you can press to perform that specific task. Then comes the most important reason to use function is to aid in an conceptual organization of a program. The biggest benefit of using these mini programs, or you can say function, is that they help you organize your thoughts and make your main program easier to understand. Instead of having one long list of instructions, you break it down into smaller logical chunks with clearer names. It's like organizing a messy room into labeled boxes. It just makes everything becomes clearer. Another reason to use function is to reduce program size. Any sequence of instructions that appear in a program more than once is a candidate for being made into a function. This just means another great thing about function is that they can make your program shorter. If you have the same set of instructions repeated in different parts of the program, you can put those instructions into a function and then just call that function whenever you need to perform that specific task. The function's code is stored in only one place in memory, even though the function is executed many times in the course of the program. This just means even though you might use a function many times in the program, the computer only needs to store the instruction for that specific function once in its memory. Here's an example of function to calculate the cube of a number that is declared from the user. So here you can see this is the main function, and this is the first function that is being declared. This function is cube, and this is used in the main function. Here you can see the cube n function is used, and in the while loop, one important thing is that the first function needs to be declared before the main function as the main function, as if you don't declare the function firstly, then the main function will not be able to run because it doesn't know what the cube function means, because you haven't declared the cube function before the main function. So it is an important thing that you first declare the function and then you just define the function. You can just define, or you can just declare the function and define the function simultaneously at the same spot, and then write the main function after. Here you can see I have rewritten the function code here in a compiler. So let's see what output it gives. Here's the output. We'll run it again. Let's enter 3. Here is the cube of the number we just entered. Then we'll enter 4. Then we'll enter 5. It just keeps on going until you enter 0. Then the code stops. So here is another example of function, that is two argument functions. In this program, you can see that this program finds the larger of the two numbers you enter, and it keeps asking you for new numbers until you tell it to stop. That means you enter the first number as 0. So let's see how it works. Here you can see that this function declaration tells the program that this function exists. Then comes the main function. It is the function where the previous program starts running, and what the program does is, like, if you enter two number like 5 and 3, then it will print max these brackets, and then the first number 5, and then the second number 3, and then is equals to the number which is greater uh, between the both two numbers. The max function here is calling the function that we have declared previously. Here I have rewritten the function code. You can see the function that tells the max number between the two numbers. Let's run it and see the output. So here we'll write 2, so 2, then press enter, then 5, and here this function tells the max between 2 and 5. So we'll write 3, enter 7. Here it is. It keeps on going until you write the first number as 0. The code stops. One more thing, that this line means that if x is greater than y, and this question mark symbol can be thought of an if statement, like if this statement is true, then we'll print x, and if this statement is false, then we'll print y. So that's all for this code. Here is an example of writing the function before the main function. As you can see, it doesn't make any difference. It just we just need to declare the function before the main function. If we are writing the function after the main function, first we have to declare, then writing the function definition after the main function. Or you can just write the function definition before the main function. Here is an example for calculating the permutations. So here you can see we have used two functions before our main function. You can see the first function calculates the factorial of a number n, and then the second function uses the first function, factorial function, to calculate the permutation. You can see the output here, and this is the main function where the second last function of the permutation is being called, and here you can see the output of this function. Here you can see a code by using function for the calculation of the GPA. Here the double uh, data type is used, and then the if else if and else statement is used in the first function. Then here's the function is declared, and here the function is called in the main function. And here you can see the output. Here you can see a C++ code for the passing by value and the passing by reference. In this code, the int x is the pass by value that changes inside the function but does not affect the original variable, and this int and y is the pass by reference, and it changes the inside function but do affect the original variable. And then comes then the system pauses. Now let's see the output of this function. Here you can see the output of that function. This is before the first call, and this is after the first call, and this is after the second call. Then comes the local and the global variables. The global variable in this code is x is equal to 10, the int x is equal to 10. The global variable is always declared outside all the functions, that is, at the top of the file. It is accessible from anywhere in the program, and it exists for the entire program execution. Then comes the local variable, that is int x is equal to 50. It is declared inside a function. In this case, it is declared inside the main function, and it is only accessible within its scope, that is between these curly brackets, and its lifetime is that it exists only while its function is executing. Then comes the scope resolution operators, that is this. It is uh, it is used to access the global variables, and this prefix before the x means look in the global scope. An inline function. A function call involves substantial overhead. Extra time and space have to be used to invoke the function, pass parameters to it, allocate storage for its local variables, store the current variables, and the location of execution in the main program, etc. This means that think of it like this: when your program calls a regular function, it's like putting your current task on hold going to another room to perform a different task, that is the function, and then coming back to where you left off. In some cases, it is better to avoid all this by specifying the function to be inline. This tells the compiler to replace each call to the function and explicit the code for the function. Now imagine instead of going to another room, you simplify copy the instruction from the other room and paste them directly into your current task. That's the idea behind an inline function. When you mark a function as inline, you're telling the compiler, hey, instead of doing the whole go to another room routine every time I call this function, just take the code inside this function and put it right here in my main program where I'm calling it. To the programmer, an inline function appears the same as an ordinary function except for the use of the inline specifier. Here's an example of an inline function uh, for the conversion of pounds to kg. The inline function just tells the compiler to insert the function codes where it's called. Let's see the output of this function. Here you can see is the code for the conversion of pounds to kg, and here is the output. Let's let input a weight in pounds, that is 129. It prints the weight in kgs. Recursions. The existence of a function makes possible a programming technique called recursion. Recursion involves a function calling itself. This sounds rather improbable, and indeed a function calling itself is often a bug. However, when used correctly, this technique can be surprisingly powerful. Recursion is much better to understand with an example than with lengthy explanation, so let's apply it to a program we've seen before. The next program uses recursion instead of a loop to calculate factorial. This program uses recursion to calculate the factorial instead of loops. Then comes returning by reference. Besides passing values by reference, you can also return a value by reference. The reason is to allow you to use a function call on the left side of the equal sign. Variable returned by the function is assigned the value on the right side of the equal sign. You can't return a constant from a function that returns by reference. You can't return a reference to a local variable. So that's it for this video. Thanks for watching.